ordered pair. Let A and B be any two sets. Let A and B, capital A and capital B will be there. Let A and B be any two sets. Then by ordered pair of elements, we mean a pair like this. This is called ordered pair XY, where X belongs to set A and Y belongs to set B. Where X belongs to set A and Y belongs to set P. Next is Cartesian product of two sets or Cartesian product of sets. Write down next definition, that is Cartesian product of sets. Let A and B, let A and B be any two non-empty sets. Be any two non-empty sets. Then the Cartesian product. Then the Cartesian product of the sets A and B. Then the Cartesian product of the sets A and B is the set of all ordered pairs. Is the set of all ordered pairs XY, all ordered pair XY, where X belongs to A and Y belongs to B. Where X belongs to A and Y belongs to B. And is denoted by A cross B, and is denoted by A cross B, and is defined as this is equals to ordered pair XY such that where X belongs to A and Y belongs to B. X belongs to A and Y belongs to B. For example, let the set A equals to the elements having 1 and 2, and set B equals to 3, 4 and 5. Okay? So if we want to find A cross B means whenever we are having cross product, in this cross product we will be having the elements like ordered pairs, and the ordered pairs will be such that the first element of the ordered pair will belong to first set and second element of the ordered pair will belong to second set. So A cross B will be 1, 3, 1, 4, 1, 5, similarly 2, 3, 2, 4 and 2, 5. This is the value of A cross B. Okay? Similarly, if you want to find the value of B cross A, so B cross A will be, now see again we are having ordered pairs, but in this ordered pair first element will belong to the set B, it will be 3, and second element will belong to set A, it will become 1. So ordered pair will be 3, 1, similarly 4, 1, 5, 1, 3, 2, 4, 2 and 5. So these are all the elements of the cross product B cross A. We can also find the value of A cross A. What will be A cross A? Now see, the set A is having the elements 1 and 2. So we are going to take the cross product of this set again with the same set that is having the elements 1 and 2. So what will be the cross product? It will be 1 1 1 2 2 1 and 2 2. Okay. First element from first set and second element from second set. No doubt the set is same, but this one belongs to this set and second one belongs to this set. After that 1 2, similarly 2 1 and 2 2. Also we can find the value of B cross B. B cross B will be, now we have to take the cross product of B with the set itself, that is 3 4 and 5. Again B is 3 4 and 5. So what will be the value of B cross B? It will be 3 3 3 4 3 5 4 3 4 4 4 5. Similarly 5 3 5 4 and 5. So this will be the value of B cross B. See, before starting the relations, we need to have a look on this cross product. If you understand these things, then there will be no problem in the relations. Okay? So it was all about ordered pair and Cartesian product of two sets. Now write down the definition of relation. You can take the screenshot, but अगर नहीं लिखा गया है तो screenshot ले सकते हो आप. Next is relations. Write down the definition. But in the paper of discrete structures, definitions and articles are very, very important. There will be definition in 2 marks or in 5 marks or 10 marks. If the definition comes in 5 marks or 10 marks, obviously after that you will be asking some quotient also. But definitions can also be in 5 and 10 marks. So relation, or it is binary relation. Relation or binary relation. Write down the definition. Let A and B be any two non-empty sets. Again, I am saying A and B are sets, so it means that there will be capital A and capital B. Let A and B be any two non-empty sets. Let A and B be any two non-empty sets. Then a binary relation. Or simply a relation R, or simply a relation will be denoted by capital R, or simply a relation R from A to B, is a subset of A cross B. Is a subset of A cross B. Cross नहीं लिखना, just write the notation A cross B. Next line में लिखो. R is a relation from A to B. R is a relation from A to B. R is a relation from A to B. If and only if. This is how we can write. This is if and only if. R is a subset of A cross B. R can be proper subset, R can be improper subset. What is the meaning of if and only if? If and only if means if R is a relation from A to B, we can write like this. R is the subset of A cross B. If we are having R as a subset of A cross B, we can write R as a relation from A to B. If and only if means both ways implies. If we are having this statement, then we can write this. If we are having this notation, we can write this. It means both ways implies. इधर भी चलता है और इधर, ठीक है? So if R is a relation from A to B, if and only if R is a subset of A cross B. Next is total number of relations. Note करके लिख सकते हो आप. Total number of relations. Total number of relations Let A and B be any two non-empty finite sets. Let A and B, capital A and capital B, let A and B be two non-empty finite sets containing M and N elements respectively. Respectively means the set A is having M elements and the set B is having N elements. I'm again repeating, let A and B be two non-empty finite sets containing M and N elements respectively. Then the number of ordered pairs in A cross B, then the number of ordered pairs in A cross B equals to number of ordered pairs in A cross B equals to M into N. Number of ordered pairs in A cross B equals to M into N. And total number of subsets of A cross B, total number of subsets of A cross B is to the power Mn. Total number of subsets of A cross B is 2 raised to the power Mn. अब बेटा you know कि relation is a subset of A cross B. ठीक है? If R is a relation from A to B, then the total number of relations from A to B will be, अगर number of subsets to the power Mn है, then number of relations, write down in next line, then the number of relations from A to B, number of relations from A to B is also 2 raised to the power Mn. So there can be a question if a set A is having M elements and set B is having N elements, or it can be any number over here. It can be 5, 4, कुछ इस तरह से कोई number भी आ सकता है, and you have to find the number of relations from the set A to set B. Then there will be to the power Mn relations from the set A to set B. Next is domain and range of relation. Domain and range of relation. Let R be the relation from the set A to set B. Let R be the relation from set A to set B. Then the domain of R, is the set of all first coordinates of the ordered pair. I'm again repeating, let R be a relation from set A to set B. Then the domain of R is the set of all first coordinates of the ordered pairs belonging to R. I will give example later on, just write it down. Is the set of all first coordinates of the ordered pairs belonging to R. Similarly, the range of R is the set of all second coordinates of the ordered pairs of the ordered pairs belonging to R. For example, let us suppose we are having element in A as 1, 2, 3 and elements in the set B as 4 and 5. Then the value of A cross B will be 1, 4, 1, 5, 2, 4, 2, 5, 3, 4 and 3, 5. This is the Cartesian product of two sets. Now to find the relation, we know that R is the subset of A cross B. It can be proper subset or it can be improper subset. Let us suppose that the relation R contains the elements 1, 5, 2, 4 and 3, 4. Okay? Wait a minute. So let us suppose that R is having the elements 1, 5, 2, 4 and 3, 4. So domain of R, it will be denoted by dr. D stands for domain and R stands for the relation R. Domain of R means the first element in each ordered pair. It is 1, 2 and 3. Similarly, if we want to find the range of R will be the second elements in this domain. It is 5 and 4 or 4 and 5, one and the same thing. So domain of R is 1, 2, 3 and range of R is 4 and 5. जहां पे function, जहां पे relation define हुआ है, that is called domain. This is the first element in each ordered pair. Similarly, range जहां पे relation आके खत्म हुआ है, this is 5 and 4. So this is range of R is 4 and 5. I hope it is clear to all of you. After that, we are having inverse relation. Write down next definition. Inverse relation. Next is inverse relation. Next is inverse relation. Write down the definition. Let R be the relation from the set A to another set B. Let R be the relation from set A to another set B. Then the inverse relation. Is a relation from the set B to set A. Then the inverse relation is a relation from the set B to the set A. Thus, if R is equals to ordered pair AB, where A belongs to set A and B belongs to set B, then R inverse is equals to ordered pair B, where again B belongs to set B and A belongs to set A. टर्म्स की पोजीशन as it is ही रहेगी, ठीक है? हमारे पास अगर A एलिमेंट A में है और B एलिमेंट B में है तो इसमें भी सेम ही रहेगी, लेकिन सिर्फ हमारे पास ये ऑर्डर पेयर चेंज हो जाएगा. If ordered pair AB belongs to relation R, then ordered pair BA belongs to relation R inverse. It can also be written as ordered pair AB belongs to relation R. It can be written as ordered pair BA belongs to R inverse. You can write it like this also. You can write it like this also. Also, it can be written as ARB. It means that A is related to B or ordered pair AB belongs to relation R. Okay? It can also be written as B R inverse A. That is, there is an inverse relationship where ordered pair BA belongs to R inverse. ठीक है? ये इसको लिखने के तरीके ऐसे भी लिख सकते हो, ऐसे भी लिख सकते हो, ऐसे. So it's up to you कि आप लोग कौन सा एलिमेंट डिफाइन कर रहे हो रिलेशन के अंदर. Also, domain of R inverse, it will be. Now see, this is R inverse. This is the element of domain and this is the element of range. In this case, this is the element of domain and this is the element of range. So domain of R inverse क्या है? Element B. लेकिन ये R का क्या था? Range element. This is equals to range of R. Similarly, domain of Similarly, range of R inverse is equals to domain of R. ठीक है, उल्टा रिलेशनशिप है दोनों में. Range of R inverse is equals to domain of R. After that, there are some types of relations. Next, write it. Types of relations. Types of relation. This is very, very important. Types of relation. There is a direct quotient. There can be direct quotient in 5 marks. Explain all the types of relation. ठीक है? So it is important. Definition भी आ सकती है अलग-अलग, लेकिन इकट्ठा क्वेश्चन भी आ सकता है. Explain all the types of relation. Explain different types of relation. Number 1, empty or void relation. Empty or void relation. Let A be a set, capital A. Let A be a set. Then phi is a subset of A cross A. Phi is a subset of A cross A is true. And hence it is relation on A. And hence it is relation on A. This relation is called empty or void relation. This relation is called empty or void relation. For example, let us suppose we are having a set A like this. Then A cross A will be, it is again equals to phi. Then R is a subset of A cross A. A cross A is having nothing. So phi is a subset of R. तो मतलब R क्या है? Void relation. Next is universal relation. Next is universal relation. Universal relation. Let A be any set. Let A, capital A, be any set. Then A cross A is a subset of A cross A. This is true. ठीक है, एक सेट के सारे एलिमेंट्स अपने सेट में प्रेजेंट होते हैं. A cross A is a subset of A cross A is true. Hence it is relation on A. Hence it is relation on A. This relation is called universal relation of the set A. This relation is called universal relation of the set A. For example, let us suppose we are having a set having elements 1, 2. So what will be the cross product of two sets? It will be 1, 1, 1, 2, 2, 1 and 2, 2. So If we take the relation R as 1 1, 1 2, 2 1 and 2 2. So R is a improper subset of A cross A, having all the elements of A cross A. So this relation is called universal relation. जब हमारे पास रिलेशन के अंदर क्रॉस प्रोडक्ट के सारे एलिमेंट्स आ जाएं, उस रिलेशन को हम लोग नाम दे देते हैं यूनिवर्सल रिलेशन. ठीक है, अगर सारे के सारे एलिमेंट्स आ जाएं तो दिस इज कॉल्ड यूनिवर्सल रिलेशन. Next is number 3. Number 3, identity relation. Number 3 is identity relation. Identity relation, देखो बेटा, रिलेशन डिफाइन करने से पहले हमारे पास एक सेट का होना जरूरी है. इफ देयर इज अ सेट, only then we can find cross product of that set. After finding the cross product, only then we can find the relation. If there is no set, there is no cross product, we cannot find this relation because relation is the subset of cross product of two sets. तो अगर ये सेट ही नहीं है, ये क्रॉस प्रोडक्ट ही नहीं है, तो इसका मतलब हम लोग रिलेशन भी डिफाइन नहीं कर सकते. ठीक है, आइडेंटिटी रिलेशन, लेट ए बी एनी सेट, let A be any set, then the relation R, ordered pair XX, then the relation R equals to ordered pair XX, where X belongs to the set A, then A is called identity relation, then R is called this R, then R is called identity relation on the set A, then R is called identity relation on the set A. Thus in identity relation, every element is related to itself only. Thus in identity relation, every element is related to itself only. For example, let us suppose we are having a set A having the elements 1 and 2. After defining the set, we can find the cross product. देखो बेटा, आगे हम जितने भी रिलेशंस करेंगे उसके लिए हम लोग एक ही सेट डिफाइन करेंगे, और जो भी रिलेशन होगा वो उसी सेट के ऊपर क्रॉस प्रोडक्ट होगा. इसके लिए दो डिफरेंट सेट्स नहीं होंगे. ठीक है, after defining the set A, we will find the cross product of that set A cross A. A cross A will be 1 1, 1 2, 2 1 and 2 2. Now the relation, identity relation says that this relation is having the elements like ordered pair XX, both the elements must be same. अब देख लो कौन सा एलिमेंट यहाँ पे ऐसा है, 1 1 2 2. यहीं पे एलिमेंट्स ऐसे हैं जो सेम है, 1 1 है 2 2 है, लेकिन ये दोनों डिफरेंट हैं, इसलिए हम इनको कंसिडर नहीं करेंगे. सो दिस रिलेशन इज नोन एज आइडेंटिटी रिलेशन. क्लियर है ये? This relation is called identity relation. If there is any doubt, beta, you can raise your hands. After that, next is reflexive relation. Next type is reflexive relation. Write down the definition. Reflexive relation, a relation R on set A, a relation R on set A is said to be reflexive relation, is said to be reflexive relation, if every element of A, if every element of A is related to itself, if every element of A is related to itself, thus R is reflexive, thus R is reflexive if and only if ordered pair XX belongs to relation R for every X belongs to the set A. If and only if ordered pair XX belongs to relation R for every X belongs to the set A. For example, let us take some more elements in the set A. First of all, we want to find the cross product of this set. It will be 1 1, 1 2, 1 3. Similarly, 2 1, 2 2, 2 3, 3 1, 3 2 and 3 3. ठीक है, ये हमारे पास क्या आ गया? क्रॉस प्रोडक्ट ऑफ टू सेट्स. After the cross product of two sets, we will find the relation R. The elements of the relation will be from this cross product only, no element from the outside of this cross product. ठीक है? Now, the definition of reflexive relation says that it contains all the ordered pairs in which element is related to itself only. And there is one condition for every X belongs to the set A. It means that we are having 3 elements in the set A. So in reflexive relation, we must have 1 1, 2 2 and 3 3. Okay. Now there is a difference between identity relation and reflexive relation. Firstly, we did identity relation. What is the difference between these two? देखो, identity relation के अंदर, suppose we are having this set and we are having the cross product of this set. If we are to find the identity relation, it can be 1 1, 2 2. It can be 1 1, 2 2, 3 3. It can be 1 1, 3 3. It can be 2 2 and 3 3. ठीक है, इनमें से कोई भी हो सकता है. ये सब एग्जांपल्स हैं आइडेंटिटी रिलेशन की. ठीक है, इनमें से कोई भी आ सकता है. लेकिन रिफ्लेक्सिव रिलेशन में बेटा देयर इज वन कंडीशन दैट वी आर हैविंग द ऑर्डर्ड पेयर्स इन द रिलेशन with one condition for every X belongs to the set A. It means that जितने भी एलिमेंट्स हमारे पास सेट A के अंदर हैं, if we are having 2 elements in the set A, then reflexive relation will contain these 2 ordered pairs, 1 1 and 2 2. If we are having 3 elements in the set A, then we must have 1 1, 2 2 and 3 3. If इसमें से एक भी ऑर्डर पेयर स्किप कर देते हो, then that relation will not be reflexive relation. ठीक है, आपके पास सेट में जितने भी एलिमेंट्स हैं उन सब के रिलेशंस अपने ही एलिमेंट के साथ रिलेशन के अंदर डिफाइन होने चाहिए. अगर एक भी आप यहाँ पे ऑर्डर पेयर स्किप कर दोगे तो वो रिलेशन हमारे पास आइडेंटिटी तो बनेगा, लेकिन ये रिलेशन हमारे पास रिफ्लेक्सिव नहीं बनेगा. ठीक है, so you have to remember this condition that reflexive relation ordered pair XX belongs to R for every X belongs to the set A. You have to write all the elements related to itself in the relation. पेपर में डेफिनेशन के बाद सिर्फ ये चीज लिखाते हो R is equals to this, तो पूरे नंबर नहीं मिलेंगे. क्यों? क्योंकि हमारे पास बेटा रिलेशन डिफाइन करने से पहले सेट डिफाइन करना पड़ेगा. सेट डिफाइन करने के बाद क्रॉस प्रोडक्ट डिफाइन करना पड़ेगा. आफ्टर दैट वी विल फाइंड रिलेशन. अगर इनमें से ये दोनों चीजें आप लोग स्किप कर जाओगे, सिर्फ रिलेशन डिफाइन करोगे, तो उस केस में नंबर भी स्किप हो जाएगा. नेक्स्ट डेफिनेशन इज Next definition is symmetric relation. Next definition is symmetric relation. Let A be any set, capital A. Let A be any set. Then a relation R on the set A. Then a relation R on the set A is called symmetric. Is called symmetric if and only if ordered pair xy belongs to relation R implies that ordered pair yx belongs to relation R. For all जितने भी xy हैं कहां से आएंगे? It must be from the set A. Ordered pair xy belongs to R implies that ordered pair yx belongs to relation R. For all x and y जितने भी एलिमेंट्स हैं वो कहां पे एग्जिस्ट किए हैं? सेट A में. ठीक है? For example, let the set A equals to 1, 2. A cross A will be 1, 1, 1, 2, 2, 1 and 2, 2. ठीक है? Relation R के अंदर 1, 1 and 2, 2. देखो, this relation is also symmetric relation. Because symmetric relation is saying that if ordered pair xy belongs to R, then yx इसका उल्टा, इसका inverse. It must also belongs to relation R. तो अगर 1, 1 है तो इसका inverse करोगे, it will be again equals to 1, 1. So relation R में आ गया ये. Similarly 2, 2 है तो इसका inverse भी relation R में exist कर गया. So this is called symmetric relation. Now come to this example. A equals to 1, 2, 3. 1, 2, 2, 1. This is called symmetric relation. If 1, 2 is there, then 2, 1 is also there. ठीक है? Ordered pair xy is in the relation R, then ordered pair yx is also in the relation R. Also it can be R is equals to 1, 3, 3, 1. ठीक है? R can be 1, 1, 2, 3, 3, 2. This is also symmetric relation. 1, 1 है तो इसका inverse. This is again 1, 1. This is again in the relation R. 2, 3 है तो 3, 2 भी है. If you write R is equals to, देखो बेटा जितने भी एलिमेंट्स मैं ले रही हूँ यहाँ पे सारे के सारे एलिमेंट्स कहाँ से हैं? क्रॉस प्रोडक्ट में से. ठीक है? इसके बाहर से मैंने कोई एलिमेंट नहीं उठाया है. सारे एलिमेंट्स यहीं पे बिलोंग कर रहे हैं. If you write 1, 1, 3, 1, 3, 2 and 2, 3. If you write like this, then this relation will not be symmetric relation. क्यों symmetric relation नहीं है? 1, 1 है तो 1, 1 का उल्टा inverse. It is again in this relation. 3, 1 है तो 3, 1 का inverse will be 1, 3. But 1, 3 does not exist in this relation. 3, 2 है तो 2, 3 भी है, लेकिन इसका inverse हमारे पास सेट के अंदर exist नहीं कर रहा है. So this relation is not symmetric relation. The definition of symmetric relation is if ordered pair xy belongs to R, then ordered pair yx must belongs to relation R. Next definition is transitive relation. Next definition is transitive relation. Let A be any set, capital A. Let A be any set, then a relation R is said to be transitive. Then a relation R is said to be transitive if and only if ordered pair xy belongs to R, ordered pair xy belongs to relation R, and ordered pair yz belongs to relation R, then ordered pair xz must belongs to relation R. If and only if ordered pair XY belongs to relation R and ordered pair YZ belongs to relation R, then ordered pair XZ must belongs to relation R. Okay? For example, let us suppose we are having a set A in which we are having the elements 1 and 2. So A cross A will be this. After that, we are to find a relation which satisfies this condition. Now, what the condition is? If ordered pair XY belongs to relation R and ordered pair YZ belongs to R, this position and this position, this element and this element must be same. Okay? If these two elements are same, then ordered pair XZ must belong to relation R. For example, let us suppose we are having a relation R as relation R will be 1, 1, 1, 2. This is transitive relation. How it is transitive? See, we are having the elements 1, 1 and 1, 2. Okay, we are having these two elements. Now this position and this position is same. तो merge होके क्या बनेगा ये 1, 2. First element from first ordered pair and second element from last ordered pair. 1, 2. तो 1, 2 तो already है यहाँ पे. तो इसलिए this relation is transitive relation. Or suppose we are having a set A as having the elements 1, 2 and 3. First of all, we will find the cross product of this set A cross A. After that, we are to find the transitive relation. Transitive relation, let us suppose 1, 2, 2, 3 and 1. This is transitive. Okay? This second position and this second position. This is same. The element will become 1, 3. We have taken 1, 3. Or transitive relation, you can take any element from the cross product of two sets, but the condition is that you have to satisfy this condition in your relation. ठीक है, कोई भी ले लो एलिमेंट ले लो, लेकिन आपकी कंडीशन सेटिस्फाई होनी चाहिए. अगर कंडीशन सेटिस्फाई नहीं होती है तो वो रिलेशन नहीं बनेगा. Transitive relation, let us suppose we are having 1, 3, 3, 1 and 1, 1. ठीक है, 1, 3, 3, 1. This element and this element is same. Now the element will be 1, 1. 1, 1 is here. We have to check all the options. अब यहाँ पे देखो, एक element है 1, 1, 1, 1. We can take this element with this first element, that is 1, 3. 1, 1 and 1, 3. Its second position and its first position is same. So what will be the new element? It will be 1, 3. 1, 3 is already there. इसके अलावा कोई और ऑप्शन बन सकती है 3, 1 and 1, 1. These two elements, this second position and this first position, this is again same. So what will be the new element? It will be 3, 1. 3, 1 is already there. तो जितनी ऑप्शंस हैं आपने सारी ऑप्शंस चेक करनी है कि आपने जो एलिमेंट्स लिए हैं रिलेशन के अंदर क्या वो हमारी सारी कंडीशंस को सेटिस्फाई कर रहे हैं. अगर तो नहीं करेंगे बेटा तो इसका मतलब आपको कंडीशन को सेटिस्फाई कराना है, तो इस तरह से एलिमेंट्स लेने हैं जो हमारी कंडीशन को सेटिस्फाई कर जाए. So this is all about transitive relation. Transitive relation, a relation is said to be transitive if ordered pair XY belongs to relation R and ordered pair YZ belongs to relation R, then ordered pair XZ must belongs to relation R. Next is anti-symmetric relation. Next is anti-symmetric relation. Let A be any set. Let A be any set, capital A. Let A be any set. A relation R on set A. A relation R on set A is said to be anti-symmetric is said to be anti-symmetric if and only if ordered pair xy belongs to R and ordered pair yx belongs to R. Ordered pair xy belongs to R and ordered pair yx belongs to R, then x must be equals to y. Then x must be equals to y. For example, identity relation is anti-symmetric relation. जो हम लोगों ने identity relation किया था, this is also anti-symmetric relation. I hope that you can give example by yourself. ठीक है? For example, identity relation is anti-symmetric relation. Next definition is equivalence relation. Next definition is equivalence relation. Let capital A be any set. Let capital A be any set. Then a relation R on the set A. Then a relation R, capital R, on the set A is said to be an equivalence relation on A. Is said to be an equivalence relation on the set A if and only if it satisfies the following. If and only if it satisfies the following. Number one, R is reflexive. Number two, R is symmetric. And number three, R is transitive. Okay? If these three conditions are satisfied, we have already done about reflexive, symmetric, and transitive relations. If these three conditions are satisfied, then we will say that the relation R is an equivalence relation. Then the relation R is an equivalence relation. For example, let us suppose we are having a relation, we are having a set A as 1, 2, and 3. Let us suppose we are having the same set, that is 1, 2, and 3. Then cross product of two sets, A cross A, it will be all the elements in the Cartesian product. After that, we are to define a relation R which satisfies these three conditions. First of all, the relation must be reflexive. Now, the condition for a reflexive relation was all the elements have relationship with itself. That is 1, 1, 2, 2, and 3, 3. Okay? So, these three elements satisfies the property of reflexive relation. After that, these three elements also satisfies the property of symmetric relation, because symmetric relation is if ordered pair xy belongs to relation R, then ordered pair yx must belongs to relation R. तो yx के relation R के अंदर होना चाहिए. तो ये property भी satisfied है यहाँ पे. After that, third property that R must be transitive. For transitive, let us suppose we are having element 1, 1 and let us suppose we are having 1, 2. 1, 1 and 1, 2. This second position and this first position is same. So new element will be 1, 2. This 1, 2 is here. लिख लिया हमने ऑलरेडी, दोबारा नहीं लिखेंगे क्योंकि एनक्लोज्ड इन ब्रैकेट है. दिस इज अगेन सेट, तो सेट में रेपिटेशन अलाउड नहीं है. सो 1 2 इज देयर. आफ्टर दैट देखो क्या कोई और कॉम्बिनेशन बन सकता है. 1 2 है तो 1 2 का कॉम्बिनेशन 2 2 के साथ बन सकता है. 1 2 एंड 2 2 मतलब 2 2 and 1 2 and 2 2. There can be this combination 1 2 and 2 2. Its second position and its first position is same. The element will be 1 2 again. So 1 2 is there. इसके अलावा कोई और कंडीशन नहीं बन सकती है यहाँ पे. So these elements form transitive relation. So this is the example of equivalence relation. ठीक है. Asymmetric relation. Next is asymmetric relation. A relation on set A is said to be asymmetric. A relation on set A is said to be asymmetric if ordered pair xy belongs to relation R, then ordered pair yx must belongs to relation R, not belongs to relation R. ठीक है. अगर ऑर्डर पेयर x y है तो ऑर्डर पेयर yx रिलेशन R के अंदर नहीं होगा. फॉर एग्जांपल, let this be the set, this be the cross product, then relation R. What will be the relation R? It will be, if we are having 1 2, then 2 1 must not be in the set. If we are having 1 2, तो 2 1 नहीं आएंगे. If we are having 3 2, then 2 3 नहीं आएंगे. So this is called asymmetric relation. ठीक है. This is called asymmetric relation. Next we are having partial order relation. Next we are having partial order relation. Partial order relation. A relation R on set A. A relation R on set A is said to be partial order relation. A relation R on set A is said to be partial order relation if it satisfies the following. If it satisfies the following. Number 1, R is reflexive. R is reflexive. R is anti-symmetric. R is anti-symmetric. And R is transitive. R is reflexive. R is anti-symmetric. And R is transitive. There is a difference between equivalence relation and partial order relation. In equivalence relation, second condition is it must be symmetric. In partial order relation, this condition is anti-symmetric. ठीक है? There is the only difference between symmetric and anti-symmetric, and I hope that you are clear with symmetric and anti-symmetric relationship. You can give the example of your own. Partial order relation, a relation having the properties of reflexive, anti-symmetric, and transitive. The property of anti-symmetric is itself contained by reflexive relation. ठीक है? Next is composition of relations. Next is composition of relations. Composition of relations. Let R and S, capital R and capital S, let R and S be two relations from set A to set B, from set A to set B and from set B to set C. From set B to set C respectively. मतलब R एक relation है from set A to B and S is a relation from set B to C. Then a relation S composite R. This O stands for composition. Then the relation S composite R is called composite relation. Is called composite relation. Is called composite relation from A to C. From A to C, where ordered pair AC, where ordered pair AC belongs to S composite R, where ordered pair AC belongs to S composite R, if and only if we can find an element B belongs to the set B. If and only if we can find an element B belongs to set B such that ordered pair AB belongs to relation R and ordered pair BC belongs to relation S. Ordered pair AB belongs to relation R and ordered pair BC belongs to relation S. ठीक है? देखो क्या लिखा हमने? Let us suppose we are having three sets A, B, and C. Now we are defining two relations, R and S. R is a relation from set A to set B, and S is a relation from set B to set C. Let us suppose we are having elements A in the set A, B in the set B, and C in the set C. A, B, and C. Okay, these are elements. Now, whenever we find the composition, we want to find the composition. If we find the composition in backward position, sets will be in the forward position. ठीक है? S composite R, इसमें हम उल्टा चल रहे हैं, तो set से हम सीधा चलेंगे. If we find a relationship, a composition from the S to R, then it will be a relationship from A to C. If we find the composition R composite S, then the relation will be from C to A. ठीक है? If we are having S composite R, then relationship will be from the set A to set C. इस चीज को ध्यान रखना. अगर हम कंपोजिशन में उल्टा चल रहे हैं तो सेट में सीधा चलेंगे. अगर कंपोजिशन में सीधा चल रहे हैं तो सेट में उल्टा चलेंगे. This is called composition of relations. ठीक है? This is called composition of relations. This is all about the types of relation, or we can say properties of relation. It can also be like properties of relation, explain all the properties of relation. Directed graph. Directed graph or digraph of a relation. Directed graph or digraph of relation. Definition is: consider a relation R. Consider a relation R on set A equals to 1, 2, 3, 4. Let the set A be having the elements 1 to 4, defined by अब उसने सीधा रिलेशन डिफाइन किया है, लेकिन जो ये रिलेशन आएगा ये क्रॉस प्रोडक्ट में से ही आएगा. 1 2 2 2 2 4 3 2 3 4 4 1 and 4 3. 4 1 and 4 3. To find the directed graph of R, to find the directed graph of R, write down the elements of A. Write down the elements of A. Draw an arrow. Draw an arrow from an element X. From an element X to an element Y. From an element X to an element Y. Whenever ordered pair XY belongs to relation R. Whenever ordered pair XY belongs to relation R. Please wait बेटा, मैं इसको खत्म कर लूं पहले. Then the figure so obtained. Then the figure so obtained is known as directed graph. Then the figure so obtained is known as directed graph for the relation R. I am again repeating. Consider a relation R on set A equals to 1 2 3 4, defined by R is equals to, R is defined over here. To find the directed graph of R, write down the elements of A, draw an arrow from an element X to element Y whenever ordered pair XY belongs to relation R. The figure so obtained is known as, the figure so obtained is known as directed graph for the relation R. क्या लिखा है हमने? Let us suppose this is 1, this is 2, this is 3, and this is 4. ठीक है? We are having 4 elements in this set. We denote these elements with these points. This is 1, 2, 3, and 4. Now see in the relationship, first element is 1, 2. 1, 2 means directed edge starting from the point 1 and ending at the point 2. After that, next element is 2, 2. 2, 2 means directed edge starting from the point 2 and ending at the point 2. Okay? Next is 2, 4. 2, 4 means directed edge starting from the point 2 and ending at the point 3. After that, 3, 2. 3, 2 means directed edge starting from the point 3 and ending at the point 2. After that, 3, 4. 3, 4 means directed edge starting from the point 3, ending at the point 4. After that, it is 4, 1. Directed edge from the point 4 to the point 1. After that, 4, 3. 4, 3 means there is another edge starting from the point 4 and ending at the point 3. So this graph is known as directed graph.